Okay, now I want to do an example in integration, and this is a rather important integral to the extent that it's given its own name, and it's called the beta function. It can appear in different forms, but this is one of them. And I've denoted the integral by IMN equals, and I've now written the integral down, and you should see that the obvious way to start off this one is to attempt to solve it by parts. So that's what I'm going to do. So that will be the first term, 1 minus x to the m, multiplied by the integral of the second, x to the n plus 1 over n plus 1, and evaluated between the limits 1 and 0, which I think you can be able to see will come out to 0, and then continuing that, the second part of the integral, which will be the integral of the first part differentiated, so that would be 1 times 1 minus x to the power m minus 1, but you've got to differentiate the inside of the bracket using the chain rule, and so that will become a minus. And again, the second part will be x to the n plus 1 over n plus 1 dx. As I've just said, the first part is 0, so that vanishes. For the second integral, you've got minus minus, which will make it a plus. So that will be 1 minus x to the power m minus 1 times x to the n plus 1 over n plus 1 dx, which you can denote in the way that I've started it off as I missed out an m somewhere. Yes, yep, there we go. You can denote that as m over n plus 1 and I m minus 1 n plus 1. Right, now you can apply that same recurring formula instead of to IMN to IM minus 1 n plus 1 and move us on to the next stage, and that will give us m minus 1 and over n plus 2. Our sort of navigation guide here would be like this. If you look at the first term, the top and the bottom add up to m plus n plus 1, and the same should apply to the second term. M plus n plus 2 minus 1 is m plus n plus 1. Okay? And then the integral part will be I, that goes down by 1, which is m minus 2, and the other part will go to n plus 2. And we can continue in that vein until we run out of numbers on the top. And we'll come down to this, m times m minus 1 all the way down to 1. Obviously can't continue beyond that because that would then be 0. And the bottom terms, remembering that the corresponding terms have to add up to m plus n plus 1. That will be n plus 2, and so on. And the last one will be m plus n. They have to add up to m plus n plus 1. Now, what about the I part? Well, if you notice that the that should then be the number after the first number after the I should be 1 less than this number here, so that will be I0, and these two numbers must always add up to m plus n, so that will be m plus n. So now all we need to do is work out what that last integral is. But first of all, we'll write this down as m factorial, and that's n plus 1 n plus 2, and so on up to m plus n. And the integral part, we'll work that out over here. So I naught m plus 1 will be simply x to the m plus n dx, limits 1 and 0. And what does that come to? That will be x to the m plus n plus 1 over m plus n plus 1. And when you put in the limits, 1 and 0, the bottom limit will make it disappear. The top limit will make the numerator 1. So that will come to 1 over m plus n plus 1. And that completes the integral. So if you know that, if you can remember it, then take an example of I naught 1 minus x to the power 10 times, say, x to the power 8 dx. Instead of taking hours and hours trying to work that out, if you remember the general form of the integral, that will simply come down to 10 factorial over 9 times 10 going on up to 19. All right, that finishes that little bit. But before I go on to that, I'll just mention that associated with the beta function is something called the gamma function, which I shall also deal with in due course. And the two together are a very effective way of conducting investigations in more advanced work.